Hello, in this video I'm going to show you how to tell if a table represents a proportional relationship. Remember that a proportional relationship has constant ratios between the two variables. So that's how we can test for proportionality, if the ratio is always the same between x and y. So I'm going to test each of these tables to make sure that when I divide y divided by x or x divided by y, I get the same number. Now, they're not going to be the same number as each other because I'm dividing in the opposite way, but as long as I'm doing the same order for each pair of variables, I should get the same thing. So let me show you. I'm going to actually color code this to show you that you can test it in two ways. I'm going to test y divided by x for each table and x divided by y to show you whether it's proportional. So I'll do y divided by x first. For this first table, I have 3 divided by 1, 6 divided by 2, 10 divided by 4. And on the other side, I would have just the opposite way. 1 divided by 3, 2 divided by 6, 4 divided by 10. Now let's calculate what those are equal to. Well, I know that 3 divided by 1 is 3. I know that 6 divided by 2 is 3. 10 divided by 4 you might not know, so I can use my calculator. My calculator shows that. I can change that to a decimal, 2.5. So right away, I don't need to go any further. This is not proportional, because 2.5 is not the same as 3. I'll prove that it would also work if you divide this way. 1 divided by 3 is 1/3. That's equal to 0.3 repeating forever. 2 divided by 6, or 2/6, is an equivalent fraction, but I can show you. 2 divided by 6 is also 0.3 repeating forever. But 4 divided by 10, 4 divided by 10 is 0.4. So once again, this final entry made it not proportional. Okay, let's test on this side. Again, I'm going to do y divided by x. 0 divided by 0. We'll get to that in a moment. 1/2 divided by 2. 9 divided by 36. And on the other side, I'm going to do x divided by y just to show you that either way it works. 2 divided by 1/2 and 36 divided by 9. Okay, let's start with purple. 0 divided by 0. That causes a bit of an issue when you try to actually calculate that. You can see on my calculator it says indeterminate, which means you can't actually divide by 0. So just keep that in mind. It turns out that any proportional relationship will have 0, 0 as a possible pair of values. If you think about it, an example of a proportional relationship is like the number of apples you buy and the cost. While if I buy 0 apples, it's not going to cost any money, so the cost will be 0. So I'm going to just put a question mark here, but so far that's fine. 2 divided by 1/2, you can use your calculator if you don't know what that is. 4. And 36 divided by 9, I know is 4. So actually this is proportional, because the ratio of x to y is always 4. When it's 0, 0, you can imagine, oh yeah, I just have to, sorry, this is like calculating how to get from y to x. I can multiply 0 by 4 to get 0. I can multiply 1/2 by 4 to get 2. And I can multiply 9 by 36 to get, 9 by 4 to get 36. Just to show you on the other side that it also works. That's still indeterminate. 1/2 divided by 2. Well, half of 1/2 is 1/4, but I'll just show you 0.25. And 9 divided by 36 is also 0.25. This is 1/4. Notice that 4 and 1/4 are reciprocals, because we're just dividing the opposite direction. So this is also showing that it's proportional. Okay, and finally, I can do the same process. You're just looking to see if you get the same number when you divide. So here I'll do the y's divided by the x's. 1.5 divided by 7.5, 1.6 divided by 8, 3.6 divided by 20. I'm going to just do this side because I already showed that either way you go, you're going to figure out if it's proportional. It doesn't matter the direction as long as you're going in the same direction. Okay, so I'll do 1.5 divided by 7.5. That gives me 0.2. 1.6 divided by 8 gives me 0.2. And 3.6 divided by 20, it gives me 0.18. So this is not proportional because of this entry, which is not 0.2. That's how you tell if a table is proportional.